Welcome back everyone to the channel, and today I'm just going to work on a very simple but powerful question. We are going to talk about how the data actually move through the network. So this is going to be a very important question because we have different media types, and some of them which are very important, we have spoken about some of them before. It's going to be cables, which are copper and fibers, and also without cable, which is going to be wireless actually. So we are going to think about the signals that we send through these media. Now these signals are going to be different. For copper, that's going to be electricity. For fiber, that's going to be light. And for wireless, we send radio waves. So we are going to see this in the context of where devices talk to each other. And also, I'm just going to talk about two concepts which are called CSMA CD and CSMA CA. The first one is for wired, and the second one is for wireless network. So let's talk about the first one, which is going to be the copper one. So the copper cable is going to be the classic one, actually, you know that. And when we have this kind of a device, this kind of a medium, what we do is we send data through that. We send electrical pulses. Now, electrical pulses, of course, have different types of standards, how we just represent ones, how we just represent zeros. And in some of them, for example, we have ones when we have some electrical signal. When we don't have, that's going to represent zero. In some other standards, we have one, which is going to be a falling voltage. We have zero when we have a rising voltage. I'm not going to go that deep actually, but we are going to talk about this. If I have a signal inside the wire, for how far I can send that signal before it fades away. And the standards, as I told you, is based on the type of the cable that we use. And also, if we want to have power over Ethernet or PoE or not. You know that, for example, for PoE, some of the devices that we really need to receive some power from, the switch itself is mostly access points, actually. So if you want to have that PoE feature enabled, then you cannot really go up to 100 meters. You need to be below 80 meters of distance. So you cannot really be longer than that, unless you have some kind of a repeater or a hub or something like that that is going to amplify the signal that we have in here. But the problem with the electrical signals inside this is you are susceptible to electromagnetic interference, specifically if you have some equipment near your cabling, such as electrical motors or fluorescent lights or something like fridge, for example. Then you will pick up some interference inside the cable. So think of it like, for example, two friends that are talking in a very crowded, noisy room. If you're close, you're fine. If you're far away, or the room is too loud, actually, you're starting missing some words. You cannot really hear everything that the other partner says to you. So that's exactly why Ethernet cables have distance limits. So why when you use power over Ethernet, like power in an access point, for example, we keep everything shorter, 70 meters, 80 meters, something like that for reliability. And what about fiber? Inside fiber, of course, we have different types of fiber, and for that, we're going to have different types of light pulses, but actually, it's going to be light pulses. Now, these light pulses are going to be generated by laser when you go with single mode, and for single mode, you have thin core for the cable, and you send laser lights that go kilometers, very far away. And when you want to, for example, connect multiple buildings inside a campus or switches that are, let's say, 2 kilometers apart from each other, copper cannot really dream of doing that. That's going to be single node fiber. If the lengths are shorter, if the distances are shorter, in that case, you're going to go with multimode. Multimode, of course, doesn't have to implement those very expensive lasers, so LEDs are going to be used for that, but of course, LEDs are not going to generate lights like laser. So for shorter distances, that's going to be okay. Inside the buildings, inside data center, inside the rack, that's going to be the way to go. So that's it. Other than that, fiber handles a very insane speeds, like 10 gigabit per second, 40 gigabit per second, 100 gigabit per second, and nowadays 400 gigabit per second. And as of this course, of course, the time of recording, actually, I have seen 800 gigabit per second switches, ports that are introduced to the data centers. They are used for AI, and the workload of AI, of course, needs that kind of a speed inside your data center. So fiber, of course, is going to be the medium of choice when you want to have faster or longer, transmissions. What about wireless? So when we go wireless, in wireless, air is where data travels, and we have devices shared between the air, of course, is going to be the shared medium for us. As a matter of fact, we are not using cables at all. So when you want to, for example, connect your laptop or phone and to an access point, so radio signals are going to be used for transmission, which means that you can move. Mobility is going to be one of the features that you have in wireless. So there are different signals, actually, there are different frequencies, sorry. 2.4, of course, goes further and farther, but it is slower and much more crowded. If you go with 5 gigahertz frequencies, it is going to be faster and cleaner, but of course it doesn't travel as far. And 6 gigahertz is blazing fast, but of course very short range. This is going to be the type of different frequencies that you use in here. So what is the catch? Wireless is a shared space. Your signals are mixing with neighbors' Wi-Fi's, microwaves, Bluetooth devices. So wireless feels a bit like walkie-talkies. If two people talk at the same time, the message overlaps and gets scrambled, right? That is why Wi-Fi, while amazing for mobility, of course, will never be quite as stable as cables. Okay, so why we need rules? So let's say, for example, we have coppers for electricity, we have fiber for light, we have wireless for radio waves, but here is the problem. What if multiple devices try to talk at the same time? Without rules, it's going to be chaos, right? I'm going to give you an example. Let's say, for example, 10 people all shouting in the room. So networking, came up with methods to share this medium fairly. One of them is CSMA CD, the other one CSMA C8. Now, CSMA CD, as a matter of fact, is used for wired network. It is carrier sense, multi-access, collision detection. But you think about this last part, collision detection, because that's going to be the important part for you. So nowadays CSMA CD might not be very useful because nowadays we use switches and each one of the ports on the switch is going to be its own collision domain. But previously we had a shared medium. So inside the shared medium, if two devices started to talk at the same time, their signals collided and got scrambled. So nobody's data made it through. So Ethernet used the CSMA CD, which is carrier sense multi-access with collision detection. And here is the rules, of course, in their simple terms. First, when you want to talk to others, listen to the wire. If wire is free, then send your data. If two devices send at the same time, then you're going to have a collision. Then you have to stop, wait a random amount of time, and then try again. So it is very much similar to a group discussion in a room. Everyone listens before they talk. If two people accidentally start at the same time, they both stop, laugh, and then one tries again a second later. It works, right? But it is a little bit clunky. So the good news is, with modern switches and full duplex Ethernet, collision doesn't happen anymore. So CSMA CD is really just a history now, unless you really use a shared medium. What about wireless? In wireless, you don't have collision detection, you have collision avoidance. So in this shared space, when you want to transmit through air, as a matter of fact, I wouldn't say through air, through space, as a matter of fact, because we talked about radio signals. We are not talking about voice. So you cannot really detect collisions in the air, right? By the time you realize it, it is very much gone, long gone, too late. So Wi-Fi uses some mechanism which is called terrestrial multi-access with collision avoidance. What are the steps? The first step, devices will still listen before talking. So if nobody's talking, then we are going to start talking. So before sending, they also wait a random backoff time. So I want to speak, but I'm just going to wait a little bit more. And sometimes they send ready to send, something like you are an airplane on a runway before, pushing the thrust lever. What you're going to do is to just talk to the control tower to get a clearance for taking off or even for landing sometimes, right? So what you're going to say is we are ready to send and wait for clear to send and then send it. Who sends you the clear to send? As a matter of fact, the access point sends you the clear to send. So very much similar to walkie-talkies. You don't just start sending a message. You just say, "Hey, can I talk?" and then wait for some time, and then the other one said, "Go ahead," and then you start talking to each other. Uh, Wi-Fi seems very polite, right? But also slower compared to wired Ethernet. That is why even if your Wi-Fi says 1 gigabit per second, a 1 gigabit cable is going to be much smoother and faster. Okay, so we spoke about everything. Here is the takeaway. Old Ethernet with hubs, we needed CSMA CD to keep things orderly. Modern Ethernet with switches, there is no collision, no CSMA CD at all. Wi-Fi, we need CSMA CA, and this is critical because everyone shares the same airways. And this explains why wired feels more stable and consistent. Wi-Fi gets messy when lots of people are on it. And let's recap. We have seen how copper uses electricity, fiber uses light, wireless uses radio waves, and to keep everything plain fair, old Ethernet uses CSMA CD and wireless today uses CSMA CA. Okay, this might sound like small details, but they explain a ton about why networks behave the way they do. And it is gold for both your CCNA exam and real-world troubleshooting. If you enjoyed this, hit that like button and subscribe button. That helps me stay motivated to make more content for you. And also stick around. In the next video, I'm just going to talk about network communication concepts, OSI model, and how host-to-host communication works. Thanks for watching, and see you next time.